Hi, now we're ready to try the experiment. So on the lab manual, if you already read it, you will see like part 1 experiment. So we need an electroscope, a rubber rod, and a cloth or a fur, right? So I have the electroscope here. So you know what is fur means. So here's a fur piece and a rubber rod. And then this is the electroscope. So some of you might be seeing this for the first time. Anyway, so this is an electroscope and it does have a metal knob here. And down here inside, you should be able to see like one metal piece kind of fixed, and then the other one is a feather, right? So that's a foil. So it's very light foil. And this equipment is called electroscope, and we are using it to demonstrate charges, right? So if you watch the theory, then you know what is a charge mean, right? So here, what we're going to do is I'm going to follow the instruction on the lab manual and do the experiment for you. So if you were here in the lab really, then you will be doing that. All right, so here, this is the rod that I'm going to rub it against the fur. So, you know, like when I'm rubbing, electrons will jump from each other and make one piece charge positively and the other one charge negatively, right? So here when I'm rubbing it, depending on the material quality, this rubber will get negatively charged. So when I rub, the negative charges from the fur jumps onto the rubber rod and make it negatively charged. I'm rubbing it really roughly so I can build up more charges on it, and then I can demonstrate this experiment properly, right? So I think it's charged enough. So here I'm bringing, I'm about to bring the rod close to this one, but if you think about the charge distribution, so you know, like this is, I don't see any movement of the leaves here, so it is in neutral condition. That means, as I draw in this picture here, the very first picture, so this is the step 1. Oh, can you see that? Right, so on the step 1, this is the initial condition. So this picture represents the electroscope. So that's the knob of the electroscope. So the knob on this one, and then these are the leaves, right? So we know, like inside this there are millions of electrons, but for understand it easily, let's think there are only 8 protons and 8 electrons in there. So here 1, 2, 3, 4, 5, 6, 7, 8 protons, and then I have 8 electrons, right? So there are 8 electrons and 8 protons. Now it is in the neutral condition, so they are equally distributed and it's in neutral condition. All right, now let's try the second part of the experiment. So what I'm going to do is I'm going to bring this charged rod closer to this knob. Okay. Do you see anything? Maybe not. So let's charge it again and try it again. I'm still on step 2. So I'm making the rubber rod charged, and then I'm going to bring it to the knob of the electroscope. Oh, now do you see, right? You see it? See? The leaf rose, right? It's rose, it's raised, right? So it's rose and it's lifted. Okay, so when I'm bringing this negatively charged rod, the leaves on the electroscope rose, right? All right, so why? What is happening there? So here I'm bringing a negatively charged rod closer to the knob here. So here, initially there were 4 electrons. Now, 4 electrons closer to the knob over here. Right now, I'm bringing a negatively charged rod. That means the electrons on the knob running away from the negatively charged rod, right? So all the negatives that we had earlier there will going away from the rod because it's negatively charged, right? So you know, negative repel. So all the negatives will run away from the rod. So initially there were 4 in the bottom of this electroscope, and now those 4 electrons that were there will rush over to down here, right? Now here, these 2 leaves does have like excessive electrons in there. So electrons repel, right? So these two leaves will repel each other. Rose, like it's raised, right? So it's lifted off. So the leaves will lifted off. So you will be seeing like the feathers are lifted off from each other. And let me try it again so you can see it. Okay, so here I'm charging the rod and I'm going to bring it closer to the knob here. So electrons inside the knob will run down towards the feathers and feathers will rise. Can you see that? That's right. Let me try it here. Yes, here. All right, now in the third step, what you're going to do is you're going to touch the knob. So I'm basically grounding it. Do you see that leaf went back? So it's went back to the initial condition, right? So what's happened there then? So here, now in the third picture, that's my step 3. So I'm touching the knob while I'm having that negatively charged rod over there. So negatively charged rod did not touch the knob, but I touched the knob with my finger, right? So I noticed that the leaves went back to the initial condition. Then the charge distribution will same as the as in the step 1. So you will have 4 protons here and 4 electrons over there and 4 electrons over here, right? So I have equal amount of protons and electrons here, so they stay together in a neutral condition. All right, now let's move on to the step 4. Okay, I need to charge this again and make sure like I do step 1, step 2, step 3, and then step 4. All right, so the leaf is rising here, right? See, when I bring it close, it's raised. And then I touch that, it went back. And when now I'm going to do the step 4, where I'm going to remove my finger and also the charge rod. Do you see that? It's went back, right? It went, oh no, hold on, let me try it again. What did we see here? It's a reflection, so it's hard to see there. Please bear with me, but you know, it's a hard situation, so we have to handle this somehow. Okay, so I'm ready. Here, I see it's lifted, then I touched that, so it's went back, and then you see like it's lifted again. Okay, now it's nicely raised. Touch it. Yes, it went back, right? So you see like it's going, the leaves are behaving like it behaved in step 2. So you may watch the video piece closely, so you will see like the leaves went back to the step 2 situation. So now here, what's happening here is when I touch this thing with my finger, these electrons will rush over to get neutralized. So it's going to get grounded, right? So when you're touching it long enough, these electrons will get grounded through my finger. And when I remove both finger and the electrons, now I don't have enough electrons over here to neutralize it. So I have less electrons than protons. So I still have those 8 protons distributed nicely, but I do have only a couple of electrons left behind. So this, because I made those electrons go away from the system to get grounded, right? So I have only couple of electrons left and it's positively charged. So positive repel, so they rise again, right? All right, so here I charge this electroscope without even touching it, right? So that's called the induction. So here I charge this using a technique called induction without even touching it. Now here we touch that and make the system charge positively, right? So that's called the conduction because I conducted some electrons out from the system to ground, right? So here this is charged again positively. So this is the conduction and it's make it positively charged, right? So from here to here, it's induction. Here to here, it's conduction. So when you're explaining your answers, please make sure to write that. And also when you're drawing pictures, so basically you're reproducing this same picture here, but make sure you draw it nicely on this picture, and then maybe you can take a photo of it and attach it to your lab report, right? So by this part, this experiment steps, you may able to answer question 1, 2, 3, and 4. So I'll make another video for the second part of the experiment. All right, I'll see you there.